Okay, good day. So, hello. For today's lecture, we're going to discuss about inertial torque and rotational kinematics. But before we go further in our discussion, let me just review what we have discussed on our previous lessons on General Physics 1, interrelated with different kinds of motion. Okay, so we have two general types of motion, okay, namely translational motion and rotational motion. So what is the difference between these two types of motion? Okay, first, we can classify this as rectilinear motion. Okay, so rectilinear motion is a motion that is on a straight line. Okay, for example, on a horizontal axis or on a vertical axis in a form of project in a form of a free fall. Okay. Second, we have a circular motion. So this is a motion when our body is going around a circle. For example, the blades of a fan. Okay. And lastly, we have rotational motion. So rotational motion is a motion of a body around a fixed line. So that fixed line is what we call as the axle or the axis of rotation. Okay. So from this following examples of a motion, okay, we could classify them, okay. So rectilinear motion and circular motion falls under translational motion, okay. While rotational motion is a different kind of motion. So how do these two types of motion differ from one uh into other? So when we're talking about translational motion, we're just translating distance, velocity, and acceleration with respect to time. So basically it is for two dimension and nothing is stopping for the whole body to move around that axis. Okay? So, sa rotational motion naman, yung body natin is moving in circles, is forming a curved path, but, okay, there is something that is attached on that body moving in circle. Okay, for example, a hinge on a door, the gears on a bicycle, and the axle for uh, a fan. Okay, that is what we call as the axis of rotation or the AOR. So for these two types of motion to be interrelated with one another, we have to convert or find the counterpart of these quantities to rotational motion. Okay, so for distance or displacement, okay, we express the quantity of change in distance uh in terms of theta or the angular displacement. Okay, the unit used for angular displacement is rad because the SI unit for angular displacement is in terms of radians. Okay, second, we have velocity. The counterpart of it for rotational motion is the angular velocity or written as omega. Okay, we use the equation rad per second. And then lastly, we have acceleration. The angular acceleration is expressed as alpha. Okay, the unit used is rad per second squared. Okay, so in order for us to uh, convert translational motion to relate rotational motion or to express these quantities on a given mathematical equation, we use this following equations. For example, for if we're going to find the distance with respect to the value of the angular displacement, okay, we could use theta r, okay, or an addition for velocity, okay, using the angular velocity, omega r. And lastly, for acceleration or linear acceleration, using the value of the angular acceleration, we use alpha r. Okay, so just take note of this equation and expression because we'll be using this through our discussion of our main topic, which is torque. Okay, so what is torque and how it is explained on a real life basis? Okay, so let us use the example or that is or that we're doing, okay, almost all of the time. It is the opening and closing of doors. Okay, so we have here door A and door B. Okay, so door A and door B. Okay, the knob of the door A is located at this part. The knob of the door B is located at this part. Okay, what do you think would be the difference between these two doors? Okay, so basing from the position of their knobs. Okay, so door B would be harder to open or close if the position of the doorknob is at the center of the door. Okay? So, why does it happen, or what is the physics behind this concept? Okay? So, the physics behind this concept is the rotational motion. Why is when you're opening the door, rotational motion yung under niya. Okay, kasi when we're opening the door, ang movement niya is a curved path. So yung curved path na yan, okay, attached to the hinges of the door, or uh that serves as the axis of rotation of that door, okay? And nag-form siya ng curved path or moment. Okay? So, magfo-fall under siya sa rotational motion. Okay? So, bakit ba yung distance R, okay, or distance D between the doorknob and the hinges affects how you open the door. Okay? This is due to okay, the torque that is produced by the force. Okay? Di ba doon tayo naglalagay ng force sa doorknob. So, pwedeng is mag-serve yung doorknob as our point of force. Okay? Point of force application. Okay. So, ano po ba si torque dito sa concept na to? So, torque is the ability, okay, of the force to create or to produce, okay, an angular, okay, acceleration, okay, alpha. So if your force applied produces an angular acceleration, you also produces torque. Okay? So the torque, thinking of this situation, comparing to A at B. So yung force na in-apply mo at yung distance sa hinges, yun yung nakaka-affect dun sa amount of torque na mapoproduce mo. So mathematically, para makita natin yung relationship na yon, we use this equation. So this is a symbol tau, okay, a Greek symbol tau used to express torque, and it is equals to F K T. So we have to get the relationship between the force applied and the distance of that force, okay, on your, okay, with respect to your axis of rotation. So we could also use tau, okay, is equals to F R vector. Okay, so torque is a vector quantity. So what direction does it follow? So it follows the direction of the force. Okay. So let's take a look on this top view perspective of our door. Okay. Para mas makita natin yung uh, effect ng force, okay? Force vector sa ating amount of torque, okay? So, dito yung hinges natin for our axis of rotation. Tapos, sige, dito na tayo sa ideal na composition or construction ng door. This one, on this part, nakalocate yung ating doorknob, okay? So, basically, ang ginagawa natin, tinutulak natin yung door perpendicular, okay, perpendicular to our body, okay, or dun sa hand natin. Pero what if, okay, imagine nyo lang, nag-apply tayo ng force F2, which is harder to open. Okay, aling force kaya or force direction ang mas mahihirapan kang buksan yung pinto? Okay, it is F2. Okay, F2 harder to open. Why kaya? Bakit kaya harder to open yung okay, F2? Kasi, okay, the angle, okay, the angle of your force direction or your force vector affects your torque. So how can we express that mathematically? Okay? So dito mapapansin natin if ito yung x-axis natin, okay? So yung F1 natin, which is ideal, okay? Ang angle niya ang angle niya is 90 degrees, and basically, yung makikita mo lang dyan is y-axis kasi perpendicular siya. So, y-axis, gagamitin mo is sine. May sine 90 degrees. And what is the value of sine 90 degrees? So, sine 90 is equals to 1. Okay? So, when you're going to use that on an equation, tau is equals to f r sine theta. Okay? So, if your F1 is perpendicular to your horizontal axis or your door, Okay, so sine 90 is 1. So you will be getting the largest value of your torque. Okay? So meaning, mas malaki yung ability mo to create or mas malaki yung tendency mo to create uh, an angular acceleration. Okay, what if ito naman, we're going to look at F2. So makikita nyo, yung angle niya, okay, angle ng 2 is less than 90 degrees. And when you're going to input a value less than 90 degrees, tapos kukunin mo yung sine niya, okay? So you'll be getting a value less than 1. Okay? So yung value ng torque mo would be lesser. Okay? So what if, yan, what if nandito naman yung torque mo, or sorry, dito yung F3 mo. Okay? So what would happen to the door? So F3, okay, at F3, your door would not move. Bakit? Bakit hindi gagalaw yung door? Kasi, basing from our formula, okay, sine theta, what is the angle of F3? Angle of F3 is 0. Okay? Angle 3 is 0 and sine 0 is 0. Okay? Same as this one, F4. Okay? So, at F4 then, okay, the door would not move because sine, okay, so sine 180 is also equals to 0. Okay, so the door would not move. If it is not moving, it would not create an angular acceleration. Okay, so kasi ang goal natin para maka-calculate tayo ng torque is makapag-create yung force na in-apply natin ng angular acceleration. Okay, so next, let us define clearly what torque is. So a measure of effectiveness of the force in producing rotation about that axis. Torque is a vector quantity. Okay, the direction of the torque vector depends on the direction of the force on the axis. So a force is required to close and open the door. So consider uh, a force is required to open the door. It is easier to open the door by pushing or pulling away from the hinge, close, or close to the hinge. So, nasagot na natin to, mas madaling i-open yung door kung yung ating hinge, okay, yung ating hinge is away, okay, away, or yung force natin is away from our hinge. Okay, same goes with the seesaw. Okay, seesaw concept. So sa pag-seesaw concept kasi, na-apply din natin dito yung meron na nakikreate din na angular acceleration and the seesaw is attached to a fulcrum. So that's why may rotational motion and may torque na napoproduce. Okay? So next we move on to inertia. Ano po ba ang definition natin ng inertia? Okay, inertia, okay, is the tendency of an object to resist change, okay, okay, in its state, okay, of motion. Yan. So, saan po ba nakadepende ang ating inertia? Okay, so according to Newton's first law of motion or law of inertia, where it states that a body at rest would remain at rest and a body in motion would remain in motion unless acted upon by an unbalanced force or an external force. Okay, so yun po yung law of inertia according to Newton. Pero saan po ba nakadepende ang inertia? So inertia depends on the mass of the object. For example, we have here two blocks. The first block weighs 5 kilogram. The second block weighs 10 kilogram. Okay, which has a greater inertia. So the greater inertia would be our second block because as the mass of the object increases, okay, its inertia also increases. Its ability to resist change in its state of motion would also increase. Okay, so alam natin dito na same, okay, same composition, same construction, different masses would create different value of inertia. Pero what if ito ay 5 kg? Okay, so they would have the same. I1 and I2 would have the same, okay, value of inertia. Pero what if, yan, we have two bodies with the same state. For example, our first object is a hoop. Sorry. Okay, a uniform hoop. Okay, assuming that this is a perfect circle, perfect object. Okay, so yung first object natin is a ring or a hoop. Our second object is a disk. Okay, uniform disk. Okay, they have the same. Okay, they have the same radius. Okay, same yung value ng radius nila. Same din yung mass nila. For example, this mass is 5 kilograms and your disk is also 5 kilograms. Okay. Tapos, nag-apply tayo ng same amount ng force, okay, or tension, kasi hinigit natin siya. Okay, same amount of tension, which is 100 newtons. Okay, thinking na nag-apply tayo ng 100 newtons tension. Wait. Okay. Yeah. So, kita natin na ito kasing mga body na to is ang construction niya is a form of circle. So, since a form of circle to, they would create an angular acceleration and then they would create torque. Okay? So, meron tayong ma-create na torque dahil dun sa tension na in-apply natin. Okay, thinking of this, okay, following equation or following different values, alin po kaya dito ang may mas malaking torque at may mas malaking inertia? Okay? So, ano po ba yung previous statement natin sa when we're talking about torque? Okay, sabi dito natin, it is easier to open the door by pushing or pulling away from the hitch. Okay? Paano po natin malalaman kung alin yung mas malayo or mas malapit sa hitch dito sa ating dalawang uh, object? Pero, okay, meron tayong magkaibang construction. Okay? Ang titingnan natin dyan is kung nasa nakalagay yung axis of rotation tsaka yung center of mass ng object natin. Okay, thinking na yung axis of rotation natin is the same. Nasa gitna siya nung, okay, radius natin. Okay, so same lang din. Ang titingnan naman natin yung center of mass. Okay, center of mass. Okay, kasi sa inertia, alam natin na ang tinitingnan natin is yung mass. Since dito, okay, kahit same yung value ng mass nila, yung distribution ng mass nila is magkaiba. Okay? So, related or aligned with the value of its axis of rotation, okay? Paano ba na-distribute yung center of mass? Dito kay Hope, makikita nyo, the center of mass, CM, okay, is away from the axis of rotation. Bakit po? Kasi 'di ba, hollow yung gitna niya. Okay, walang nakalagay dun sa gitna. So basically, yung mass ng object ay malayo dun sa axis of rotation. Okay, that's why pwede nating ma-conclude na yung center of mass, okay, it's away from the AOR. So how about this one? Okay, makikita natin, yung center of mass natin, nandun talaga mismo sa AOR. So, CM, okay, is distributed, okay, on the AOR. Okay? Bakit natin to inanalyze? Kasi according to our torque, okay, our torque concept, if the AOR is away from our, or if our force is away from our AOR, okay, so may mas makikreate tayong or mas malaki yung torque na mapoproduce natin. So, pag mas malaki yung torque na mapoproduce natin, okay, may relationship siya doon sa inertia. Okay? So, dito, yan, if a CA is away from our AOR or the center of mass is away from the AOR, it has or it would have, okay, a greater inertia. Okay, if a CM is distributed on the AOR, okay, it would have lesser inertia. Okay, meaning itong hoop would be harder to rotate or would be harder to create, okay, a movement, okay, uh, get with relation to our second object, which is the disk. Okay, so inertia is the natural tendency of an object to resist change in their state of motion. If an object that is free to rotate about an axis is difficult to set into rotation, its moment of inertia about that axis is large. Okay, so ito yung sinabi natin, free to rotate about that axis, okay, it's difficult to set in rotation, so its moment of inertia about the axis is large. An object with small inertia is easier to rotate or set in rotation. Okay? So, since hindi lang naman isang or object yung ina-analyze natin, we're analyzing object in terms of a system. Okay? If a body is considered to be made up of tiny masses or collection of masses M1, M2, M3 at the respective distances of R1, R2, R3 from an axis, its moment of inertia about that axis or about that different axis is I. Okay, our moment of inertia, M1 R1 squared, M2 R2 squared, M3 R3 squared, and so on, or summation of MI RI squared. The unit of inertia we use is kilogram meter squared. Okay? Since we're talking about uh, collection of masses on a system. Okay? So, we have to get the center of mass of that specific system. Okay? And nag-iiba din yung radius ng center of mass na yon. So, it is convenient to define that radius into the radius of gyration K for an object about an axis by the relation I is equals to mk. So, yung r dito, pinalitan lang natin ng k kasi we're talking about m or the total capital letter M or the total mass of that object. So, hence, k is the distance of that point mass, okay, center of mass must be from the axis of the point mass and is have to have the same I as our objects. Okay, so that is the equations we're going to use for inertia. Okay, so before we go further in our discussion, let us review, okay, these quantities for rotational kinematics, specifically for angular speed, angular acceleration, and angular displacement. Okay, for angular displacement theta, okay, it is equivalent to 1 revolution, 360 degrees, or 2 pi radians. But the SI unit we use for angular displacement is in terms of radians. Okay, next we have angular speed, omega. Okay, the angular displacement over the change in time. Okay, omega is equals to the theta over time. So next we have angular acceleration. The change in angular speed, omega, over the change in time, t. Okay, or delta omega f or delta omega over delta t. So that is our angular acceleration. Okay, so now let's go further on the derivation of torque and angular acceleration. Okay. Based from our Newton's second law of motion, where F is equals to ma, and we're going to talk about angular acceleration or angular values. Okay, para malaman natin na yan ay in form of a circle or a rotation, kailangan lagi yung may radius. And we have to, okay, get that radius, okay, na may relationship sa ating in-apply na force. Okay, so pwede nating i-multiply both sides with the value of our radius vector. Or multiply by F is our torque. Okay, so yun na-derive natin kanina. Okay, so also, since linear yung acceleration natin, kailangan natin i-convert yung linear acceleration into or makita natin sa equation natin na meron tayong angular acceleration. So sabi natin, ang linear acceleration transformed to angular acceleration is using this equation. Okay? So pwede natin i-substitute itong values na to dito. So m times alpha r, okay, multiply by r. So pwede nating i-simplify yan. M alpha r squared. Okay? So ano po ba itong equation na to? So according to the moment of inertia, m is equals to r squared. So pwede natin yang, okay, i-convert na lang into, okay, or i-simplify into using the value of moment of inertia I. So torque, okay, using angular acceleration is equals to I or the moment of inertia of that specific object multiplied by angular acceleration. So dito parang ang ginagamit nating equation is in kilogram meter squared. Okay? So this is same as, okay, F is equals to ma. So this is just the transformation of the translational motion to rotational motion when we're talking about, okay, forces and torque. Okay, so pwede dito from this, okay, from this expression, pwede nating ma-convert, or pwede nating ma-conclude na yung torque, para magkaroon ka ng torque, dapat meron ka ring force, or the force and the torque is directly proportional to one another. Okay? And then for I, yan, or inertia, directly proportional din yan sa mass mo. Okay, pag increase ng mass, pag-increase ng inertia. Pag increase ng inertia, pag-increase din ng mass. Okay, and then sabi natin itong dalawang values na to, this angular acceleration and linear acceleration is just a transformation or relation between our two types of motion. So alpha is also equal to A. Okay? So dito, parang pinakita lang natin, ay, same lang pala. Okay, same lang pala ng equations ng rotational and translational. Okay, inaano lang natin siya, tinatransform lang natin siya. Gumagamit lang tayo ng different quantities na para ma-distinguish natin na yung motion na yon may hinges na curve path, or yung motion na yon is on a linear basis. Okay? So, sa a torque T or tau acting on a body of a moment of inertia I produces in it angular acceleration alpha given by the equation tau I alpha. Okay, so yun na-convert natin kanina. Okay, so make sure lang na ang gagamitin yung equation is for inertia, it is kilogram meter squared. For torque, Newton meter. And for acceleration, rad per second squared. Okay, so pero since merong motion yung object natin, okay, it changes its state from at rest or on when it is moving. Okay, so lahat ng may moving body, okay, meron din po yung kinetic energy. Okay, the kinetic energy of a rotational body. Okay, since dun na-discuss natin on our previous lessons that on linearly, para ma-compute natin ang kinetic energy, we use this equation, 1/2 mv squared. Okay, dun sa ating previous derivation, alam natin na ang I, okay, is equal to m. Okay, tapos ang V is equals to omega. So para makita natin or ma-distinguish natin, ay, yung kinetic energy na yun hindi linear. Siya ay rotational. Nakapag-create siya ng rotational motion. So we just use this equation. I-convert lang natin yung mga different values natin or quantities natin in terms of rotational values or quantities. So 1/2 I omega squared. Okay, where I is our moment of inertia, okay, na nakadepend sa mass ng object, and omega squared is our velocity or angular velocity. Okay, since we're talking about energy, its unit is in joules. Okay, next we have angular momentum. Same with angular kinetic energy or rotational kinetic energy. Linearly, para ma-compute natin yung momentum ng isang object, we use P is equals to mv. So, ito yung linear. So, kung kukunin natin ay angular momentum or rotational momentum, ang mass natin, di ba, is inertia. Tapos, ang velocity natin is omega. So, gagamitin lang natin itong equation na to. Okay? So, doon sa ating nakita activity kanina, dun sa hoop versus disk, okay? Makikita natin doon na even though same yung state ng objects natin, but they do have different construction or composition, makaka-affect yan dun sa value ng moment of inertia ng object na yun. Okay? So, kaya nag-form tayo or nag-formulate tayo ng isang theorem to prove that concept. At yun ay tinatawag nating parallel axis theorem. So, parallel axis theorem is the moment of inertia I of that body about an axis parallel to an axis through the center of mass of that object. Mathematically speaking, I is equals to ICM, where I is our moment of inertia. Our ICM here is the moment of inertia about an axis through the center of that mass of the specific object. M, okay, is the mass of our body. H is our perpendicular distance between two parallel axes. So we have here different objects, okay, basic objects or basic construction of that system, okay, na pwedeng mag-create ng angular acceleration. Okay, so this is hoop or hollow cylinder. So we use the equation I is equals to mr squared. So meaning, since ito yung ginagamit natin for hoop or hollow cylinder, itong composition na to, okay, yung may basic, okay, form ng moment of inertia. Okay, so we also have uniform disk or cylinder. So we use equation 1 half mr squared. Kasi dito, according to our previous slides, distributed yung center of mass within the disk. Okay, so para makita natin yung relation ng distribution of center of mass into the axis of rotation, we could use the constant 1 half. Okay, for uniform rod, okay, 1 uh, over 12 m or our mass times L squared. So yung L squared dito is yung length ng rod natin. Okay, next is uniform rectangular block. So, 1 half M. Since yung block natin, meron yung sides. Okay? So, para makita natin sa equation, so we use A squared plus B squared. And then, lastly, we have for uniform speed, or sorry, uniform sphere, I is equals to 2/5 mr squared. Okay, so makikita nyo dito, different construction may have or may do have a different value of a moment of inertia. Okay, so yeah. This is take note, this is for just uniformly, okay, uniformly constructed body. What do we mean by uniform bodies? So ito yung may pantay-pantay na lengths, pantay-pantay na dimensions. Kung yan ay irregularly shaped or deformable bodies, iba po yung gagamitin nating equation which we would be applying concepts of calculus. So you're going to get the derivative or differentiation of that specific dimensions. Okay? So now let's take into action our formulas that we have discussed. So let's start with this problem. A wheel of mass 6 kilogram and a radius of gyration, which is 40 centimeters, is rotating at 300 RPM. Find its moment of inertia and its rotational kinetic energy. Okay? So, hanapin muna natin yung unang unknown. It's moment of inertia. Okay? Uh, but first, let us write all of our givens. Okay? Para hindi na natin siya hahanapin. So, 6 kilogram. Ang radius of gyration natin, K, is 40 centimeters. And it's rotating at, okay, R na lang, 300 RPM. Okay, RPM. Okay? So, unang unknown natin, A, is the moment of inertia. So, paano natin makukuha using the equation I m k squared. Kasi ang given natin is the radius of gyration. Okay? So, ang mass ng object natin is 6. Okay? And the moment of gyration is 40 centimeters. But since laging SI unit dapat yung gagamitin natin, so it should be 0.40 meters. So, yun yung gagamitin natin, 0.40 meters squared. So, I is equals to, or the moment of inertia is equals to 0.96 kilogram a meter squared. Okay? So, that is our first unknown. Okay, our second unknown is the rotational kinetic energy. So, gagamitin natin equation dyan is yung na-derive natin kanina, KER is equals to 1 half I omega squared. But since wala po tayong angular velocity na in terms of radians per second, so we have to convert this one. Okay? We have to convert this one to radians per second. So how do we do that? So omega or angular velocity is equals to, since 300 ito, revolution per minute. Okay? So 1 minute is equals to 60 seconds, and then 2 pi rad over 1 revolutions. Okay? So, omega, so cancellation method tayo. Yan. So, the omega or the angular velocity would be equal to 31.4 rad per second. So, yun yung gagamitin natin dito sa ating equation to get the kinetic or kinetic energy rotational. So 1/2, ang moment of inertia natin, yung na-calculate natin kanina, 0.96. Okay, ang angular velocity natin would be 31.4. So KER is equals to 0.47 kilojoules. Or KER is equals to 0.47 times 10 raised to positive 3 joules. Okay, so that is for our first problem. Okay, now we move on to our second problem. A 500 kilogram uniform sphere. Okay, so kalagay dito, sphere of a 7.0 centimeter radius spins at 30 rev per second. On an axis through its center, find its A, KE, or kinetic energy, B, angular momentum, and C, the radius of gyration. So let us list down all of our givens. Okay, so M ng sphere. Okay, we have to take note, nakalagay kasi sphere yung ating object. So 500 kg. Its radius, okay, is equals to 7.0 centimeters. So convert na natin yan. 0.07 meters. Okay, and it moves at, okay, velocity niya is 30 revolution per second. So first unknown is, yan, what is its kinetic energy? Okay, R. So equation is 1/2 I okay, I is equals to angular speed squared. Okay, ang wala tayo dito is yung moment of inertia at saka yung omega squared. So we have to first find out that values or that quantities. So let's start with moment of inertia nung sphere natin. So ang moment ng inertia ng sphere natin, okay, let's take a look at this. So it is equals to 1/2 or 2/5 rather, 2/5 mr squared. So yun yung gagamitin natin. Okay, 2/5 mr squared. Okay, so 2/5, yung mass ng object natin, ng sphere is 500, and yung radius niya in meters is 0.07 squared. Okay, so yung I ng sphere would be equal to 0.0098 or kulang ng 0.00098 kilogram meter squared. Okay, next, yung angular velocity. So, yung revolution per second, 30. Okay, rev per second. So, since nasa second siya, convert na lang natin siya into radians. Okay, ang radians is 2 pi rad. Okay, over 1 revolution. So, the angular speed would be 188 rad per second. So, yun na yung ilalagay natin dito. Okay? So, 1/2, yung value ng I ng sphere, 0.00098. Okay? Multiply by 188 squared. So, KER would be equals to 0.017 kilojoules or 0.017 times 10 raised to positive 3 joules. Okay, next we have second unknown natin, angular momentum. So angular momentum, di ba? PR is equals to I omega. Okay? So para makuha natin yung angular momentum, so kunin natin ulit yung I. So that is, or moment of inertia, 0.0098. Tapos yung angular momentum na 188. So para makuha natin yung angular momentum, which is 0.18 kilogram meter squared per second. Okay? And next up is for radius of gyration. So radius of gyration, pwede natin yung makuha using I is equals to mk. Okay? Since alam natin na yung I na moment of inertia ng sphere na yan is 0.00098. Okay? Tapos yung mass ng object is 500. We could, Okay, multiply by our unknown, which is our k, dividing both sides with 500. So k is equals to 0.044 meters or 4.4. Yan. Para whole number siya. 4.4 centimeters. Okay? Last problem for this set. Okay, an airplane propeller has a mass of 70 kilograms and a radius of gyration of 75 centimeters. Find its moment of inertia and how large a torque is needed to give its angular acceleration of a 4.0 revolution per second squared. Okay, yan. Lagay ulit natin yung mga givens natin. So, given mass 70 kilogram. Okay, radius of gyration, which is 75 centimeters. Convert na ulit natin sa meters, 0.75 meters. And angular acceleration, which is 4.0 revolution per second. So, ang una nating unknown is its moment of inertia. So, I. So, pwede natin gamitin yung mk squared. Okay? So, simply, okay, lagay lang natin yung mga givens natin. 70 times 0.75. Okay, so yung I natin, or moment of inertia of our propeller would be equals to 39 kilogram meter squared. Okay, so next up is the torque. We're going to find the torque of our, okay, propeller. So we know using the angular acceleration that the formula for torque is I angular acceleration. But yung angular acceleration natin is in revolution per second. So kailangan nating i-convert ito, okay, into rad per second squared. Okay? This should be squared. Okay? So paano natin yan gagawin? So 4.0 rev per second is nasa square na siya. Okay? Multiply na lang natin sa 2 pi rad, okay, per 1 rev or 1 revolution. Kasi 2 pi is equivalent to 1 revolution. So angular acceleration is equals to 8.0 pi radians per second squared. So yun yung lalagay natin dito. So torque is equals to 39 multiplied by 8.0 pi. Okay, so the torque for the propellers are 0.99 kilo Newton meter, or torque is equals to 0.99 times 10 raised to positive 3 Newton meter. So that would be all for this lecture. So kindly go back to our, if you have question, kindly go back to our lecture, or please do message me if you have one. Okay, so I hope you would have a great day ahead of you. So stay safe, stay hydrated, and stay sanitized. Goodbye and thank you. See you again on our next lecture.